Alright, let's do example number 4. Again, we're going to solve, but this time we're going to do an inequality as opposed to an equation. Now, you want to be careful and know the difference between the two. An equation has one solution. Well, I got to take that back. If it's a quadratic equation, it could have two solutions. But an inequality will definitely always have a large set of solutions. So that's the big difference. And it'll have an inequality symbol. In this particular case, it's less than or equal to 5x plus 6. So remember that this is less than, and because it's got that little equal sign or equal. Okay? And so we do this problem just like we did the last one. I'm going to distribute the 3 through the parentheses first. Positive 3 times x is a positive 3x. Positive 3 times negative 1 is a negative 3. The plus 2 doesn't do anything but hang out for a while. And then I've got 5x plus 6 over here. Alright. So now I want to add up and combine like terms. So negative 3 is a number, 2 is a number, so they're like going to be best friends forever. And so we add them up and they become what? Negative 1. And 3x kind of stays by itself, so it's 3x minus 1 is less than 5x plus 6. Okay? We want to get the x's by itself. Remember, that's our goal. X equals some stuff. I was trying to draw a star. That's an ugly star. So what's the smaller of the x's, 3 or 5? 3. So I'm going to subtract 3x from both sides. And this leaves me with negative 1 is less than or equal to 2x plus 6. Need to get the x by itself. So what do I move? The 2 or the 6? We're moving the 6 just because it's easier. We could move the 2 now. But remember, when we have a number in front of the letter, it's always easier to save that step for last. Okay? The reason for that is that if I divide this by 2, then I have to divide this by 2, I have to divide everything by 2. But if I subtract 6 now, it works out pretty fancy-smancy because I only have one number on the left-hand side of the inequality and one term on the right-hand side. And so I save myself a little bit of work of dividing. Right? So that's why we always leave that last part of dividing by the number in front of x for last. Alright, so 2 times x. Want to get the 2 away from the x, so we do the opposite of times, which is divide. So I'm going to divide both sides by 2, and that's going to give me negative 3.5 is less than or equal to x. Now one way you could write it, there's another way that you could write it. How would I write it this way? What inequality symbol would I write in here? Greater than or equal to. Now, there's a fancy way to think about it, but really, which way is the inequality pointing to? The negative 3.5. Which way is the inequality pointing to? The negative 3.5. Does that make sense? Okay. At some point in time, we'll graph that. So what does that answer mean if we say x is greater than negative 3.5? Is that one solution or many? Many. Could 5 be a solution? Could 6 be a solution? How about a gazillion, trillion, billion? Yeah. So we need to let somebody know that our solution is a big one. So another way we could do that is we could talk about going from negative 3.5 to how far could we go? Infinity. Are we including negative 3.5 in our solution set? Yep, so I put a bracket. This is because we're saying equals. Now, infinity isn't really a number that we can reach, so we use a parentheses. Okay? So that's what we call the solution set. Any